I'm going to talk about Chapter 13's general rules of probability, just a few things that I want to mention when we talk about the specific rules. The general addition rule is if you have two events, A and B, for instance, being a 1 on a die and being a 2 on a die. For any two events, we could have the probability of A plus the probability of B minus the probability of A and B. That works across the board, but if the events are disjoint, there is no intersection, so the A and B do not exist. It's a zero value. So we can shorten it to just adding the probability of a 1 on a die and the probability of 2 on a die. Disjoint, again, means that two events cannot happen at the same time. Another way to say that is mutually exclusive. When things are mutually exclusive or disjoint, they have no intersection. If one occurs, the other cannot. I cannot roll a 1 on a die and a 2 on a die at the same time. They have to happen. It's one or the other. Can't be at the same time. Something that might not be disjoint is if I'm talking about the probability of being a student who's in a math class and the probability of a student who's in a psychology class. I could be in both a psychology and a math class. In our addition rule, we have the probability of a math student, the probability of a psychology student, but you notice that if I have any that are both math and psychology, if I was just to add the entire math population and the entire psychology population, I would have double counted the math psychology people. So I need to account for that by subtracting that and away. You might see or as a big U for union, and you might see and as the upside down of that for intersection. We have a rule about independence and multiplication. An event is independent if knowing that one thing occurs does not change the probability that the other occurs. If they are independent, we can multiply the two. So knowledge of one thing does not change the probability of the other. They are said to be independent. But if you know something and it impacts the probability of the other thing, they're not independent. If I have two things that are independent, I can multiply to find their intersection, the probability of A and B. The multiplication rule works with independence. If your events are not independent, if it's not stated, you cannot just do the probability of A times the probability of B. And it's very important that you separate independence and mutually exclusive. Disjoint means that if one happens, the other cannot. And so you absolutely know that they are dependent because the probability of event A determines whether B can happen or not. So a disjoint is dependent. So you want to keep those two kind of in your mind. The special multiplication rule only works if you're independent. If not, we need to talk about conditional probability. Conditional probability is when you have given one thing, this is the probability of the other. So the probability, when I read this bottom statement here, I would say that as the probability of B given A. The slash straight up and down means given. The probability of B given A. That is equal to the probability of A and B, so the intersection of the two, divided by the probability of A. What I'm doing here, and I could write this as the probability of B given A is the probability of B and A. It doesn't matter if I say A and B or B and A, it's the same thing. But I'm dividing by the given. Remember that when you're doing your division. The general multiplication rule works for any events regardless of whether they're independent or not. When I account for not just doing the probability of A times the probability of B, I say the probability of B given A. That helps me determine what the intersection is. And B given A is in conditional probability. And you can extend this rule for multiple events, probability of A and B and C. You can continue that with the givens. You show that two things are independent if the probability of B knowing A or given A is equal to just the probability of B, because knowing A or being given A does not affect the probability of B. That's all I have about general rules of probability.